Good morning, everyone that's joined. We'll be starting in just a couple minutes. All right. Thank you all for joining. And those that can't join, if you're able to watch the video, your presence is always appreciated. So I will be one of the instructors, one of the guides today for the webinar. My name is Cody Henson. And alongside, we also have Rich Burfield, who is another instructor consultant. And Rich will be here to help field any questions that may come up. So the main way to, to interact in this webinar format is through the chat function. So feel free to log any questions or comments that you may have along the way. And Rich will help monitor that chat box and jump in and answer questions and help in any way that we can. So today is day one of a 3-day webinar series covering the CoPilot and the Hub, getting the most out of your CoPilot and Hub. Day one today, we'll be focusing on the cycle graph, previous cycle screen, alarm settings, and the summary graph. And if you are able to join us for day two, that topic will be templates, how to create them, why to use them, how to work to get back towards a template if we've drifted away from one. And then day three of this series is focusing on the Hub. So hopefully people are able to join all three, but those are the agendas for each day. If there's one topic or area that maybe you're a little bit more interested in. So looking at our CoPilot screen, I'm using a web browser, which might be something that you utilize in your facility. This is connected to a virtual CoPilot. So once it's running, it's pre-populated data that is just running on a loop. But when you are viewing on a web display, one of the things that you might want to do is change the zoom. So we start out at 100% full zoom, but typically this views better if you can zoom out to about 75 to 80%. So that shifts this screen up a little bit here, but it will make all of the other content fit the screen much better. So looking to have our CoPilot collect some data, if we click on this icon or pull down the tab here, we already have a machine, a mold, and a process selected. Just a sample trial. So I would want to start the job to start collecting data. So I will try to click Start Job. And you may have noticed that there is a red bar that has popped up. Improper sensor setup. So I'm going to try that again, just in case you missed that bar, because this is something that we do have to account for before we start jobs. So again, trying to start the job, I generate an error. The screw bottom's position must be set. So to set that, and that is something that must be done before the job is started, we will go to this expansion menu up in the corner, and we can go to the setup. And we see we have many options that we can select. Most of them have a green box around them, green check boxes inside of them, and our screw bottom has a exclamation mark trying to draw our attention, red outline around the box. So when I click on that, it tells me to click the button to set the screw bottom position. Now, because this is a simulated data, I'm not actually at a machine. I can just click set screw bottom and it turns green and takes it without me having to do any action. In production at a machine, right, you will have to physically drive your screw to the 0 position fully forward and then press and set the screw bottom. I know I have, started up a machine working on some process development, got started where I went to go start the job to start collecting data, and then I had not set my screw bottom. So then I have to stop my machine, shoot my shot out to set it. So if we can try to remember to setting screw bottom before we start the machine, that will save us a step of having to stop the machine and setting screw bottom. So now that I have set screw bottom, the CoPilot is now aware of where the 0 position is for my screw. I can now go back and start the job. So starting the job populates a few screens, or we refer to these 4 quadrants as cards. You can change what cards you're viewing, as we will discuss. But to get some of the other data, it needs to run a few cycles. So while it is doing that, we can start to look at the cycle graph. Now, one of the differences, if you're at your CoPilot, at your press, you're likely using a touchscreen, where I'm going to be using a mouse to move and navigate. I will try to call out some of the differences between using a mouse or a touchscreen. But if I look on the cycle graph, and I would like this to be bigger, I have a couple ways that I can do that. I can click in this center of the quadrants, click with my mouse or touch and hold, and I can drag to resize this. So that is one method. Or if I were to double tap or double click the cycle graph, it will quickly go back to its quadrant view, or from the quadrant view, double clicking, double tapping the cycle graph will fully expand that view. So looking within our cycle graph, right, we've got a graph that we know and love to provide us with machine data and mold data. And we've got a column. It's in short form here. If I click this arrow, it will expand these icons to give some labels with them. And I can start to have some labels with the different colored lines that are being plotted. If you are just interested in looking at a specific line, you could tap to hold or click to hold to isolate a curve. In this case, just viewing the plastic pressure from injection. Or if you don't want to click to hold, you can click and drag this a little forward and release your mouse or release your touch, and it will isolate that curve. If I want to see the plastic injection pressure and the stroke volume, I can slide out just those two. If you have a lot of sensors, high cavitation, this graph can display a lot of data, but sometimes the piece of information we're looking for can kind of get lost in the noise of all of that data. So it can be helpful to isolate specific curves that we're looking for.
Hey, Cody.
Yes.
So I got a question on these curves. Like the eDart, we could change the color of the curves. Is that possible on the CoPilot?
No. So the hard answer there is no on the CoPilot. That was something that was an option on the eDart, but that is not an option on the CoPilot.
Okay, thank you.
Okay, thank you. So continuing to look at the curves, you can isolate them by clicking and holding or by sliding out. If you drop down slightly, there is an add or remove button. So if I click the remove, I can come up and these become X's, and I could remove the RJG stroke volume screw. So I've selected it to be removed, and then I would need to hit apply.
Cody, I don't mean to interrupt again. We do have another question out there.
Yes, please.
Okay, from Mr. Smith. Can you select, I believe you're getting to this. He's asking, can you select certain points on the graph to see curve values like on the eDart?
Yes. Yes. Short answer. Well, short and long answer is yes and yes. Yes, you can. And yes, we are going to get into that in a little greater detail here shortly.
Okay. And just one more, I'm sorry.
No, please. This is the interaction that we desire. This is fantastic.
Yeah, I know it is. Another question is, how do we change the curves from overlay or single cycle? I believe you're going to be getting into that as well.
Yes, I will. So I will answer both of those questions before we leave the cycle graph to go into the other cards.
Okay, thank you.
Thank you. And keep them coming, because yes, we will be getting into the two questions that were asked, but you very well could ask a question that we're not getting into, that we could potentially. So continue, please. The interaction is greatly appreciated. So I had selected, I'm going to just kind of cancel out and back up. If you want to add and remove the curves, you can click remove, select which ones you would like. That does not remove them until you hit apply. The other button is add. So if there are curves that you are interested in that you are not displaying, you can click add, and then you need to decide, is this a machine curve that you're interested in? Some data from the machine? Is it some sort of mold curve or some composite? So not adding or removing any curves, just kind of showing that you can if you want to isolate specific data. There is one more little button in here, the 3-dot menu up at the top. That is a menu for tomorrow, because that's going to get us into our templates. So I'm going to close this out, or I'm not going to close this out. I'm going to collapse the curve menu. And the question of getting specific values. So I have to click and hold with my mouse to have my cursor create a line. The touch screen, I believe you just tap, or you may slightly have to hold, but you do have to hold the mouse down for a couple seconds to get your line to be generated. Once that line is generated, you can take it across anywhere in the graph and pull specific values for the specific curves. So
we do have one more question up there, Cody.
Yes.
Since you're kind of on this cycle graph right now, it's kind of, the question is, what are the most commonly used curves? And mainly, I can kind of try to answer this as well. We're going to look at our velocity curve, our pressure curve, and our in-cavity pressure sensors.
Yeah, that's fair. So, and it kind of depends on maybe what that customer is. If you're just monitoring your machine health and performance, right, you may be dialed in on those curves. If you have cavity pressure sensors, those are going to be ideal quality markers, indicators that we could look at and monitor to ensure we make a good part. We want to duplicate the conditions inside the cavity to continue to supply, the same part over and over. But displaying machine curves is a good troubleshooting, useful tool to make sure the machine is performing the way that we expect it to, or that the way that it has historically.
I agree 100% with you.
So if I'm just trying to pick a curve to look at, we could look at the stroke volume, right? And the cursor icon works the same way. Just for reference here, we need to think of 0 towards the top of the graph. Right? So the shot size starts at the bottom of the graph. And at the beginning, we are at the full shot size. And as the screw travels forward, going up in the graph, which is closer to 0, reaching its final fill position, returning to build its shot to return to that starting point.
Yeah. And on that RJG stroke volume curve, that's why it's a must to set screw bottom, so it knows where our cushion is and everything.
Yes, that's perfectly tied in. Having this scale correctly and be useful is critical to having that screw bottom set correctly. So we can place a cursor to see our values, right? This looks like the pressure stage looking hydraulically. This is displaying in plastic pressure, but it looks like it's, packing, holding, 4,800 plastic PSI. But oftentimes we're trying to look really close at some specific event. Maybe we're trying to look really closely at a transfer position or the rise of a cavity pressure curve. So to zoom in on a CoPilot on the floor, it's going to be what we're accustomed to with a touchscreen, where we pinch to zoom. So you can pinch to zoom in and out and look deeper into a section of the cycle. With a mouse through a web interface, I have to make sure that my curves are expanded. So I need this menu expanded. And then I can go down below add and remove, and I can select a time range. So once I do that, this bar at the bottom, I'm going to open it back up. This bar at the bottom becomes a selectable range across the timeline. So I'm looking at this range here, but if I tighten this up, I get a deeper, clearer view of this part of the cycle. If I really just wanted to see the fill portion of the cycle, I could zoom all the way into here. Now you can leave this zoom at this resolution if you want, and grab the whole bar and pick which part of the cycle you're zoomed in at. I have to let it refresh, right? So here we can see the holding, pack and holding staging dropping off, and screw recovery beginning. Or you can grab either side of your time range and expand that so you can see more. Touch screen, you're going to pinch to zoom, or you can just manipulate this slider bar across the bottom. Slightly different from using a mouse and a keyboard setup. So I'm going to zoom out just enough to where I can kind of see everything. I have to click done with the mouse and keyboard, so I get back into a view that does not manipulate the time. And then we can talk about another tab on the screen, which ties into one of the questions that was asked. Over here in the right corner, I can pull this tab out, and it gives me two quick actions of showing overlays and setting the fill volume. So we currently do not have a fill volume, right? There's a little I there, no value at the fill volume. So let's start by setting the fill volume. And this is important to do if you are running a D3 process. Because we are going to, in a D3, we're going to pack using a velocity. The machine can't differentiate the fill from when it's the fast fill speed to that slower pack velocity. The machine wants to calculate that all as fill. So we need to determine an agreeable point on here where we are transitioning from our fast fill speed to our slower pack velocity. Right, and that right there looks like a pretty acceptable area where we went. I'm looking at the hydraulic pressure. right somewhere around here, it looks like we transitioned from our faster speed to our slower speed and started packing with our slower velocity. So since I have this point selected with my cursor there, I can set fill volume. And now the CoPilot knows that that is the volume of material that we are calling fill. And any remaining volume of material that's going in is going to be considered done during a packing phase, even when we're using velocity to achieve that. So bringing that out, collapsing that out. The other quick action, right, that you can slide out is to show overlays. So I can click show overlays. The button goes from blue inactive to green to show that it is inactive. And what will happen now is that it will continue to overlay each cycle on top of each other. So essentially, it will continue to draw this graph over the previous graph over and over again until that feature, hide overlays, is selected. Now, you may see the lines getting slightly thicker, but just keep in mind that I'm running simulated data on a loop. So this is going to be, about as repeatable as you could get because this is just a loop of data repeating. If you don't have a loop of data repeating, then this overlay is a very useful tool to pick up and detect viscosity shifts in your material. And it can also help you understand whether your process can absorb those shifts in viscosity successfully. And when I say successfully, I mean, can the process produce the same cavity pressures that provide a good part, even as the material viscosity starts to shift? Right.
Hey, Cody, real quick.
Yes.
Question came in. Can you adjust the number of overlays that we display?
Ooh, that is a good question. I don't have an answer to that right this moment, but I can definitely table that and try to provide an answer likely on the next webinar.
Okay, yeah, that sounds good. I will also look into it because I think right now it's just overlays. It's a continuous thing. We cannot select how many, but I'm not sure. But between me and you, we can find out for tomorrow to answer Logan's question.
Okay. Yes. That'd be great. When we talk about the hub, in essence, because I will cycle through some previous data with overlays, you can kind of select how many you overlay by how many steps you click forward, but it's not a value that you put in, right? It's not like 50 cycles and then it does it.
Yeah, that's correct. I know the hub is different than the CoPilot. I do believe the CoPilot is just one right after the other and you cannot select it, but I need to verify that as well.
Yeah, thank you for that. Thank you. And thank you for the question. So again, my line's a little thicker, but you're not going to see any kind of dramatic shift because this is pre-populated looping data. So I'm going to hide the overlays. And you can see we went back to just the previous cycle. The other thing that can be useful from this tab is, right, if you look, like we have an expandable menu for the curves, right? And then over on the other side, we can pull out for the overlays and the fill volume. And then at the bottom, there is another tab that might be useful. And that will pull up the machine sequences. So whatever triggers you may have, this is looking into like your ID7 module in your machine. It will tell you when these triggers are coming on and coming off, which can be useful if you are troubleshooting or having issues getting triggers, or things just don't seem to be happening in the sequence that they typically would. This one is displaying 3 triggers. Injection forward, and we can see that comes on at the beginning and has a little down step where it says off, which is right at the end of holding. And also notice that wherever you display your cursor at the cycle graph, you now have a cursor along the bottom that will give you data on that line as well. Below injection forward, we have a mold closed, and then there's a screw feed. And just another tab, you may not have it up often, but if something is not happening the way that we think it should be, it is a useful tab to look at to make sure things are firing appropriately and when we would expect them to be.
All right, Cody, I'm sorry, I got one more question here. So does this include the OR2 triggers for like valve gates and all that when we're down there?
I don't have one up with a valve gate.
If I'm not mistaken, I believe it does show it. That's another thing I have to verify as well.
Yes, because that is going to be another one, because I don't want to give just off my head information. So I would prefer the opportunity to verify it. And those are sequences, that we do monitor and care about when they come on and off. So let me table that one also to get you the best answer. These questions are good and appreciated. So that is a look at our cycle graph. I can grab this square in the corner and reshape and size it again, or just double click to bring me back to a quadrant view. Now, before I fully go to another card, something that some users might be interested in, right, is I will show these cards are changeable, right? We're currently displaying the cycle graph, the previous cycles, summary graph, 2 summary graphs. But you could display 2 cycle graphs if you wanted. So if you come to the dotted menu in the corner of these cards, you can pick which card you want. And if you have, a lot of cavitation, maybe you want to look at, just some post gates on one, and some end of cavities on another. It's just something else to keep in mind. I mean, you could theoretically display 4 cycle graphs if you wanted to, with all different curves on all of them. But it is just an option. And the last little bit about the cycle graph for today. So looking at another card, I will go back to the previous cycle values. And right now this card is blank. So let's go ahead and double click to expand it and start adding some values that maybe we would like to care about and track. Maybe we care about the cushion and the cycle time. And once I've made my selection, it turns green. As you can see, if I go back, I kind of went a little over it too quickly. On cushion, you know, it's black and this little round, you know, the roundness of these icons, this is changed to an arrow telling me, you know, I've got another selection to make. You know, go to the next menu. So if I follow the arrow, then I need to pick either stroke length or stroke volume. And once I've picked one, then I can go to the next thing. And this is green. Cushion is now green, saying it's good. You've made your selections. Cycle time, there is no other sub menu to select. So just maybe a couple values that we're interested in. Let me look at, we're not going to do template yet. So average cavity fill time. It's peak pressure, and then that's a good one. So the bubble becomes an arrow telling me I need to make another selection. End of cavity. And then I need to decide if I want to view one cavity or view all of them. And once I've made my selections, I need to save them. And it will start to populate the previous cycles. So the previous cycles are useful for a few different reasons, right? Maybe you are charting and logging, you know, specific information on a day-to-day basis. So you can have this heads-up display to quickly give you that information. Once we get into templates, we can discuss how this previous cycle values can start to show you how aligned or misaligned we may be with our templates. If there are anything that you want to remove, just like the add button, you don't go into another menu. Once you click remove in the right corner, you get the minus symbol. That way you could just remove or select what you want to be removed. And another example, once you click it, it does not remove it. You just selected it. And then you have to click apply, and it will remove that value. You know, right now it's without having a template, it doesn't have a template value to compare it to or a difference to generate. Not using a template, it's just a quick way to see some useful information. So I'm going to double click, or you would double tap to get back to a quadrant style view. And I will go back into the previous cycles tomorrow with a template on top to try to expand on some of the value of this card, specifically when you're using templates. So 2 quadrants left, both have the summary graph, but I can make these whatever I want them to be. So I'm going to start by making this one some alarm settings. and I'm going to double click to expand, or I could grab and drag. And it has populated a couple of alarm settings for us, similar to the previous cycles, excuse me. We can click remove, which changes this icon in the right from a pencil to a subtract symbol. Or we can go in and add. And maybe you want to add some alarms around your cycle time or your fill time. So now we have, looking at the mold, peak pressure at the end of cavity 4. Right. And again, we don't have a template value to compare it to. So our previous cycle for end of cavity 4 was 4,000. If I come all the way over to the pencil icon, that becomes an edit, if you will. So I can then put alarm bands around a lower and upper limit for peak pressured end of cavity 4. Now, right, I could put some numbers in here, but I do just want to caution that if you're ever creating the upper lower limit for, peak pressured end of cavity, this is kind of our flag in the wind, so to speak, if this part is good. Usually the thing that we're monitoring to tell some secondary piece of equipment, hey, this part is good for regular inspection. And this really needs to be done with quality in mind on the floor. And what I mean by that is if we've established that, peak pressured end of cavity 4 being 4,000 makes this a good part, right? I would encourage you to run a few trials, right, of peak pressure end of cavity 4 at, looking at the lower limit, right? Maybe run one at 3,900 and then 3,800, because you want to detect, right? Of course, we don't want to send short shots to a customer or anybody downstream for us, but we would like to detect this before it's a full short shot, right? I would prefer to detect a defective part maybe when it's got some sinks prior to being a full short shot. So running those trials to see where, hey, I don't have a short, but this part maybe has enough sinks or dimensionally isn't good enough, right? And that's going to be my lower limit. And then your upper limit is enough to where you're protecting your mold in your machine and not flashing and damaging. It's really the lower limit where you have to do diligence and run trials and understand how risk adverse you are to making sure a defective part doesn't get to the next customer or consumer. So I'm going to set this lower limit really tight. I'm going to set it really tight because I've seen it dip a little below that. And we'll just put this at 4,500. So if it goes below 4,020, it will alarm. If it goes above 4,500, it will alarm. And then I can click save. So I have set an alarm band around cavity pressure on, end of cavity 4. And I set it a little lean because I've believe some of these cycles may go below that. Now, the machine values for fill time, you can edit that also. But there is also a calculator function where you can set this based on a sigma. You can set it based on a percentage. And if I go up and click the master pencil button, that gives us an option to quickly edit everything without going into individual ones. That gives us a master calculator. And that also introduces the idea of warning limits. So just to back up a little, I'm going to back up to this screen. All right, we can set alarms individually. We can go up to the master edit where we can edit them all. They're all editable at the same time. But from here, if you go into that master calculator and you're interested in warning limits, you can turn those on. And warning limits are set as a percentage. So you can create what range away from your bottom and top generates a warning. This is entirely optional. But if that's something that you wanted to do, you could do that. And I set these so tight that that is turned yellow, and indicating that that previous cycle was a warning. Set something for our fill time.
Yeah, Cody, so will the warning limits reject parts also, or just a warning popping up?
Yeah, that's a great question. They will not reject parts. This just generates either a warning screen on your CoPilot, or if you decide to utilize a light tree, this is how you would utilize that yellow warning light on that light tree.
Okay, so that might answer the other question. Is there a signal output for warning limits?
Yes, that's where it ties into. You could have it. I believe you could also have it perform a secondary operation. For example, maybe if you wanted to deposit the rope, if you wanted a secondary deposit position for your robot for additional inspection.
Okay.
Other than that, it's mostly used to signal a yellow warning stack light.
Yep, a caution or to a yellow light, like you said, the light tree or something like that. Something might be going out.
Yeah, just to try to draw the user's attention over there that, hey, maybe something has shifted with the plastic conditions that's pushing you closer towards your limit than you normally are at.
Okay, thank you.
Yeah, thank you. Edit those out. I'm going to double click to get back to quadrant view. And then I'm going to pull over to the summary graph and expand that. Double clicking. This is similar to the time movements on the cycle graph, where if I look up in the top left, it says displaying the last 24 hours. You can change that to the last hour, last 8 hours. We started the job together, so there is only this little bit of data that has been running. So looking at the last hour is okay here. But across the top from that last hour, I can zoom in deeper if I want, just like the cycle graph. And similar to cycle graph and previous cycle values, we can add and remove. So it's populated with lots of data that is typically utilized, but you can add additional trends. You can add all that encompass. Oh, I hadn't done any with triggered alarms. Let's see if I did the other one. All trends, fine. Okay. So you can add machine trends, mold trends. Once we talk about template trends, we'll come back and add those. And then similar to our summary graph, you can move your cursor. Oops, you can move your cursor along and it will highlight whichever value you are currently on. Want to look in a little closer at some of the recent things we were doing. Along the bottom, where it says selected time range, there's some keys that tell us if we have any warnings. Any changes are changes around alarms, creations, modifications. Red is when alarms actually occurred. So I can key in on this cycle, and I know that this is where I originally created the alarm around cavity 4. And then if I key over to this, just because I was doing the adjusting, this starts to give me an indication where I generated the alarm because I intentionally set the cavity pressure a little low. When I get in, looking across here, we can see additional changes and then warnings. If you don't, you can drag your finger or mouse along to select a specific point, or you can use these arrows to jump from cycle to cycle.
We got a question, wants to know, how would you get the cursor to show up again?
So for myself using a mouse, I have to click and hold. I have to click and hold the mouse to get the cursor to show up. And then I have to continue holding the mouse as I drag it along.
Yeah, correct. Now, them and their facilities on the CoPilot, it will more than likely be a touch screen. You'll just touch your finger on it, then it will show up and you can drag it along.
Yes. Yes. So the other interesting thing that you can do from here, because the other way to think about the summary graph is to think about it as a trend graph, right? Here is where you would start to look for shifts in the data, where that would tell you that something different has occurred. Now with the cycle time, let's just focus in on the cycle time, right? Because if we continue to drag along, right, we're about 18.3 seconds. And then there's a shift to 18.36. Now it looks like a large step here, right? But we just have to keep in mind that, what is the scaling that we're talking about, right? And 0.36 seconds, I'm sorry, 0.06 seconds is not a very significant amount of time. But what this will catch, scrolled a little aggressively there, right? Because this can show a whole lot of data. So what this will catch, though, is, the question, did somebody change something on the machine, a shift ago? If you are looking at the last 24 hours of data and you want to look at something like hold pressure hydraulically, right, any shift in hold pressure, right, that is usually one of us went to a machine and physically made a change into the machine, right? Because that should be a constant pressure at whatever the value that's inputted is. Right? So a step change on hold pressure, right, could be a good indication that the change was made there.
Hey, Cody.
Yes.
Again, we got a lot of questions coming in, so it's good. So real quick, so when we drag it to a warning or alarm, how do we know which output was in question? And then,
okay.
Yeah. And then
No,
one more. And then the other questions are the alarm limits displayed on the summary graph to see how it is running within the limits? I don't know if you drag back over to that alarm, will it show you that alarm and which one of the things were out?
Yes. Yes and yes. So let me start by removing. Wow. So we have to find which of these alarmed, right? As far as peak pressure post gate, was it the recovery time, right? Which condition? So looking right here at peak pressure end of cavity 4, that's the one that we put the alarms on and bands around. So hopefully you're able to pick up on the display a little bit, but on peak pressure end of cavity 4, we now have a dotted line that starts right at this creation of this blue note right here. And now that I'm selected, it tells us that cycle was 4,045. Our low is 4,020 and our high is 4,500. And then as I scroll over, see, we have, just like we have the red alarm warning dot here, we have it. You'll only have it on that condition that we created the alarm around. Right, so that tells us there we had that condition on this cycle. So that helps me identify which, if I can find the alarm at the bottom, then I can scroll up and down to find which piece of summary data generated the alarm. And then once we created the alarm bands, that's what created the upper and lower limit on the summary graph. So I'll show a little bit more. Are there any other questions right now, Rich?
Yeah, we got one more out there. I hope that answered the last two. One from Brian. They had an issue with the summary graph. The peak end of cavity curve was reading an average pressure rather than the peak. So reloaded the curve and they still had the average. And then loaded the average end of cavity curve and it reads the same as the peak. Is that a timing issue or a timer issue? Then they had the template and reset the fill volume. And that was it.
Okay. I do not know the answer to that first question.
Yeah, we'll go through this together at the end. Yeah, that one I want to look into as well.
Okay. And then as we come to a close here, we're scheduled for an hour. I just want to note that this little above the time selection where I can select last hour, 8 hours, there's these two arrows pointing at each other. That's also an overlay. So having this cycle selected, if I click that overlay, it goes from blue to green. And if I go back into my cycle graph, it has now overlaid that alarmed cycle on top of my current cycle. So if we wanted to try to dive in and see if we could understand what was different on that cycle compared to a quality cycle, you can use that overlay function and it displays your current value, and then you have an O value indicating the value of the overlay. So if once you've realized you've generated an alarm, if you want to compare that alarm state to the current condition, that is the button that you would select to do that, is this double arrow icon in the corner of the summary graph.
Cody, yeah, I know we're running out of time, but there is just a couple more questions out there.
Yes, let's just do questions.
Yep. One person asked, Richard, I love the name, by the way. How do we add notes? I did reply. I believe we talk about that tomorrow, about adding notes.
Yes.
Okay. And another question, is there a way to create or change alarms for a job that's not running when they analyze the qualification run data? If I'm not mistaken, you can do that through the hub. You might need to correct me if I'm wrong on that one.
We're going to try it.
All right. And then the last question, does the CoPilot calculate values the same as the eDart? For an example, like the fill time, the cooling time, and stuff like that. And I believe the answer to that is yes, it does calculate it the same.
Yes, I can't think of any glaring examples where it makes a calculation very differently.
Okay. So just to answer someone else's question about the CoPilot, can it use the triggers that Cody had showed everybody on the bottom using the OR2 for like valve gates? It will show up the D to P, and I am still looking into a valve gate trigger, but it does show the V to P.
Okay, thank you for that.
And right now, I believe that was, I'm looking right now, Cody. What's the difference between fill time and process fill time? Okay. You want to answer that one, Cody, or you want me to?
Have at it.
Okay. Fill time is first stage. Process fill time on the machines side of it is injection forward. The whole time it's moving forward before screw recovery.
Excellent. Really do appreciate all these questions.
Yeah, it's great.
Well, hopefully we got everything answered as well as we could, and we'll do a little bit of research on the ones that we want to provide a little bit more clarity on. I appreciate everyone joining today, and greatly appreciate all the questions. Rich fielding those questions. Very helpful. So I hope everyone can join us tomorrow, the next two sessions.
Yeah.
Again, Appreciate everybody's time. Thank
Yep,
you.
Thank you all for attending. We'll see you tomorrow.